a safe drilling operations. Okay, so we have almost two boundaries, one on the left hand side and the other one for the right hand side. So if you are dealing with such permeable formations like sandstones, limestones, so you will be cautious with the pore pressure itself. So if you use the mud weight lower than the pore pressure, for sure it will resulting in kick or flow events while drilling it, and in consequences you may find another Macondo accident on your rig. On the other hand, on the right hand side, you will be afraid of exceeding the mud weight for the fracture pressure. So if the mud weight is a little bit higher than the fracture pressure, you may just resulting in reopening the natural fracture, so resulting in a minor mud losses. While if the mud weight is exceeding the fracture pressure with a high margin and it's too high, it may resulting in induced fracture, so resulting in a permanent or the plastic deformation, resulting in so on the other hand, what if I'm dealing with formation with low permeability like shales? So you will have another boundary other than the pore pressure, which is a shear failure that you have to consider. And here is this margin that you have to use mud weight higher than the breakout limit or the shear failure, just to keep your hole safe without experience any shale or any problem may result in the stuck of the string of the VHA and the drilling string. So, but on the other hand, again, if you have used high weight higher than the fracture pressure, even we are talking about the shales, it may be a little bit brittle, so it may resulting in fracking the rock itself. So to build this model, we need first just to highlight and to clear some basic pressure parameters that it's really important to be highlighted, which is some geometrical parameters. So it's a very common figure, as you know. It's illustrating for you what is the different geomechanical parameters here, starting from the overburden pressure. Overburden pressure, as you know, is basically the pressure caused by the weight of the rock above a certain point, at a certain point. And it's affected by the vertical weight at each point, okay? So what I want to highlight here is the overburden is very significant, very important, and it is the first chain of the cycle of the geomechanical workflow. If it started to be built in a wrong way, will be in the wrong way, and it will resulting in a poor geomechanical modeling. For the hydrostatic pressure, it means it's the pressure exerted by the column of water or of fluid, okay? So the pore pressure will be the pressure exerted by a fluid from the pore space itself. What is the difference between pore pressure and hydrostatic pressure? As you know, in the normal formations, the pore pressure is equivalent or equal to the hydrostatic pressure. Once you find out that the pore pressure is higher than the hydrostatic, so it's called overpressure zone, okay? The fracture pressure is a pressure at which the formation started to be frac. The effective stress is the difference between the overburden gradient and the pore pressure, but in other words, it is the actual stress that's gonna be felt from the formation itself. So the lithostatic or a vertical stress or the overburden gradient is the stress on the formation.
I believe your voice is a bit cracking. Why?
Yes.
Well, can you hear me? Your voice
yes,
is a bit cracking. Your voice is cracked a little bit.
So can you hear me right now clear?
Yeah, I got you now. Okay.
Still? Okay. So again, the effective stress is the difference between the overburden gradient and the pore pressure. and it reflects the actual stress for the formation that's gonna be felt from the formation. As the overburden will represent the stress by the vertical section, while the pore pressure itself will support the formation against this stress. So the difference between them will represent the effective stress. The overpressure again is the difference between the pore pressure and the hydrostatic pressure at a certain point. And the under pressure, as you can see here, it's some sort of regression of the pore pressure lower than the hydrostatic pressure itself. So it was some definitions important for our session, but actually what I need to highlight for you here, this word overpressure. Overpressure, we have to be familiar why does overpressure develop in the first place, and you would find that the overpressure causes one of the most important and significant